Hello, good morning, good afternoon, and good evening. I think we have some attendees across the world. My name is Basil Ismail, and I'm proud to have the opportunity of presenting today, which is going to be on your insider scoop into blockchain, the technology that runs Bitcoin and 1,700 other cryptocurrencies. And we sincerely hope that you enjoy and like the content that we're going to cover today. So really at a high level, what we're planning on doing is first spending some time talking about myself, my direct hands-on experience in the blockchain space, how I have been completely obsessed and just absolutely addicted to this entire area and this domain as it's been rapidly growing. And I'm very pleased to see the massive traction that it's finally picking up, and the momentum and the speed and the velocity of this growth that you're seeing in the space is just intoxicating. It's incredible. So talk a little bit about my story, then we'll jump into giving you maybe an overview over what blockchain is, what exactly is Bitcoin, and then just giving you a very, the fundamental principles behind cryptocurrency and the new craze behind ICOs and all of the other ways to raise capital. And then thirdly, once you have a basic understanding of what Bitcoin and blockchain is, actually just show you real life applications that are running on top of the blockchain today, where you can have an opportunity to see it and then prepare some questions. And then throughout, please ask questions, write them in the chat. And we have a whole team of folks who are looking at those and going to service them and do everything we can to be able to answer as many questions as we can throughout the session. And then I also wanted to, throughout the session, we're going to open it up for polls and just keep it interactive and try to keep it fun with the questions. I think some of the answers will shock you. So let's get started. So who am I? So my name is Basil Ismail. I am right now the CEO and co-founder of Blockgram. And you may or may not have seen it already out in circulation, but it's a blockchain and financial technology recruiting company. And basically, our specialty and our focus is matchmaking services, where we find hard to locate, hard to secure competitive talent in the blockchain, cryptocurrency, and financial technology spaces. And then we screen them, thoroughly vet them. And we actually leverage blockchain and distributed computing technology in being able to complete due diligence on candidates. And then we place them with clients such as Fortune 50 firms and so forth, and even up and coming and booming blockchain companies who've just finished ICOs and raising capital, who are looking for these folks. So actually at the end of the session, I'll do a whole section on who are blockchain professionals and what type of market participants are there. And can, I'll give you an overview of who those people are. So that's what I'm currently doing. My background is, I did my educational standpoint. I did my undergraduate in computer network engineering, and then I did a Master of Science in Information and Security and Risk Management from Norwich University in Vermont. And then I did my MBA from Cornell University in New York, which also happens to be extremely bullish about cryptocurrency and blockchain. So I've worked in different companies, American Express, Yahoo, Goldman Sachs, and different. So I have some experience in different sectors. But one thing that you'll see in common throughout a lot of the content that I'm presenting today is that I definitely have a natural affinity towards financial system integrations, financial engineering, machine learning algorithms, information security and risk mitigation. So all of those spaces and all of those different disciplines actually together, they fit very nicely and very neatly towards why blockchain is just so disruptive as a technology. So that's about who I am. So we've gone through this already on what is blockchain, why does it matter, what are the key features. I'll show you those. I'll show you some common uses across the two most common cryptocurrencies, which are Bitcoin and Ethereum. And I will mention now that Bitcoin and Ethereum are examples of different cryptocurrencies that are running on their own independent version of a blockchain. Okay, and these are publicly available blockchains that these are just applications that are running on top of blockchain. Then I'll walk you through the day in the life. So first things first, let's do a poll, and we will open it up now. So you should be seeing a poll on your side. So what is your level of familiarity with blockchain? And we'll share the results afterwards, but it's just good to get a good idea of, you know, the level of proficiency and expertise and exposure you have in this space. I'm assuming most of you are probably just jumping into this in the last 12 months or so, because that represents probably 99% of the users in this space right now. Okay, just a few more seconds. All right, thank you very much. So let's share the results. So right now, there is around 89% of the attendees have less than 1 year of experience. And there's a few of you that have about 1 to 5 years of experience. So that's helpful. That's actually very helpful for us to know. So that doesn't change in terms of the core content, but I will not be jumping into knee deep into the weeds and walking you through the granular components of blockchain. But so what is a blockchain? At a very high level, it is a technology that allows you to have distributed trust. For the first time in history, you are able to process a transaction such as sending money or receiving money from one person to another without actually having to trust a central governing body. So, simple example, the first application of blockchain technology is, of course, the infamous Bitcoin, which was released in 2009. And really what it is that Bitcoin, what makes it so incredible and so beautiful in its own right, is that it's a currency that is not backed by a central sovereign nation or a governing body like the United States, right? Treasury. It's not governed by Canada as a country. It's governed by the people, by the network, and it's governed by thousands and thousands and thousands of computers that are all contributing towards the safety and the security and the stability of the Bitcoin network, right? And that's running on top of the blockchain. So why is that important? It's important because there's a problem that has been plaguing cybersecurity and software engineers for decades, which is something called the double spend problem. And what that means is that today, if I go to Best Buy and I spend $1,000 to buy a new television, I can, using my credit card from Chase, I can immediately go back home after receiving delivery of the device and then call Chase and complain and pursue an arbitration and try to reconcile the loss, right? And I can convince Chase that my credit card was stolen and it was misused without my strict authorization, and that's it. And they'll process the refund, and then who loses? Best Buy loses, right? So you always need some type of third-party central arbitration point that functions essentially as somebody who enacts power over you. And ultimately, it's in their eyes, their version of the truth is what dictates the decision that's going to take place after that, right? So you always have to establish trust with them. So whether or not they are a company or an independent escrow person, or they are a title and lending and escrow company, when you're purchasing a house, for example, you always have to place trust into that title agency. But what happens in the situations where that central body or that central party that's supposed to arbitrate the transaction between party A and party B disappears, or goes bankrupt, or has financial distress situation where they can no longer be up and running and they're no longer functioning as an arbitrator that's unbiased, then what happens then, right? The transaction falls through, and one party, either party A or party B, struggles to pursue what they are owed, right? So that's blockchain is it's an improvement on technology to, rather than having everything centralized, it's decentralizing everything. So some people are calling it, digitalization of different aspects of information security. Some are claiming that the security landscape is changing. It is changing substantially, just because of the amount of mathematical science that is and the massive breakthroughs that have happened because of blockchain technology. It's the first time that we've been able to solve this double spending problem. It's the first time that we can finally, establish and distribute trust across a network of participants rather than a controlling body of a board of directors, for example, the core 7, right? Rather than focusing and trusting the core 7, you end up trusting an entire network of 5,000 computers or 5,000 people behind those computers who all have a vested interest in making sure that the network is safe and the transactions are secure and clean. All of this is leading into, a high demand of cybersecurity and distributed computing software engineers. So this space is just exploding at this point. Let me give you a glimpse into that. So right now, what I like to do when I typically do these educational learning and development sessions is I show the ecosystem. So I think this usually shocks people because they realize, wow, this space is massive. And this actually just shows you hundreds of just blockchain-oriented companies. There are thousands of other traditional companies like Microsoft, Expedia, Amazon, Intel, and so forth, who are also pursuing blockchain and distributed computing very aggressively because they realize that this is a massive disruptive technological paradigm that's going to have a vast-facing impact on everything that we're doing in terms of value exchange and value transfers, right? So an example of what the blockchain projects are working on today, and I was mentioning there's around 1,800, the majority of those 1,800 projects, like Decred and Arc and Litecoin and Qtum and so forth, they raised funding using something called ICO. So typically companies, like Microsoft and American Express and Goldman and so forth, they raise capital by issuing stock, and they go public following an initial public offering or an IPO. But in the blockchain and cryptocurrency space, people raise capital using an initial coin offering or an ICO. So it's the competition between an IPO and an ICO. And then there's something recently now that initial security offerings, initial token offerings, those are different variants of the fundamental ICO model of raising capital. But ultimately, whenever you hear somebody saying, I have a blockchain project, I'm doing an ICO, it is being used to raise capital, and those funds are then being used to build projects and products that are going to be used by users such as ourselves. So examples of those projects are really broken into these 8 groups, right? So currencies, some of the ones that we already talked about, Bitcoin, NEM, Decred, Stellar, Ripple, right? So Interledger, all of these different cryptocurrencies are essentially evolutions of the first version of Bitcoin that was released, okay? So, and you're gonna see a lot of cross-pollination here. So there's sometimes examples of projects like Ethereum, for example, which is, to me, is the most significant player in the space, up there with Bitcoin or alongside Bitcoin, because it opens up a whole world of applications that can run on top of Ethereum. So Ethereum is essentially a Bitcoin, I would say a complementer rather than a competitor, and it's a general purpose technology platform. So it's a general purpose technology platform that enables around 85% of the projects that you're seeing here. So around 85% of the projects are being operated and run on top of the Ethereum platform. Okay, so just take a second to process that information, right? That's a significant hold over the network. And the best part of Ethereum is it's completely public, transparent, and it is not controlled by some kind of benevolent dictator or a group of the core 7 I was telling you about before, the infamous board of directors. This is controlled by almost 10,000 computers and people behind those computers who are donating and contributing their amount of time towards securing the network in exchange for money. And that's called mining, and we'll jump into that later. But those are currencies. Developer tools, I sort of shadowed on top of that. An interesting one I wanted to highlight is called RSK. So Rootstack is a company, doesn't have an actual cryptocurrency, but what they're trying to do is evolve Bitcoin into becoming almost a platform that you can develop smart contracts on. So examples of smart contracts, and this is the question we always get, is what exactly is a smart contract? So how is it different from a cryptocurrency? So smart contract is essentially just like a contract you sign today with an employer, or you're signing a non-compete or a confidentiality or a non-disclosure agreement, say, where it's between yourself and the employer, or yourself and a business partner. A smart contract is essentially taking those contracts, taking all the terms and conditions and the covenants and the line items from those contracts, and then putting them up into a distributed network that essentially automatically will enforce the logic and the terms of those contracts. So simple example, if there is a smart contract that is between so if you're doing a bet, right, with your friend about who is going to win, the World Cup, is it going to be Brazil or is it going to be France? And if one party is saying, I think it's going to be Brazil, and the other party says, I predict that it's going to be France, you can actually put all the terms and conditions into an Ethereum-based smart contract, for example, or a Neo-based smart contract, which is another competing developer-based crypto platform, Neo. So Ethereum, you can have a smart contract that says, party A predicts that France is going to win the World Cup, or party A is going to predict Brazil is going to win the World Cup, party B is going to predict, France is going to win the World Cup, and then whoever wins is going to automatically receive $100 from the opposing party, right? And you can have all of that into a smart contract, and immediately when the results of the match come in, the smart contract will execute, and it'll automatically enforce the logic, which was determine who the winner is and transfer the money as so, right? So there's no questions, there's no debate, there's no arbitration, there's no, oh, it looks like there was potentially some penalization that was unfair, there was potentially the ref was biased towards one team. All of those things as they are remain, and the contract will run as programmed. So that's the beauty of a smart contract. And imagine the possibilities of smart contracting in the future and how that can spread. So a lot of these are actually running their own versions of different smart contracts on top of Ethereum. So there's different sovereignty-based ones. There's value exchange. There's shared data. So rather than using one central server of data, you end up distributing and decentralizing all of that work together. So rather than putting all of the overwhelming stress and load on one person, you end up distributing the stress and load across an entire network of computers that are essentially hosting all of that data for the network or for the company, right? So there's public and private variations of this. And then there's prediction markets. So the one I was just walking you through an example of the battle between, Brazil and France, you can actually program these in Augur and Gnosis. And what they're trying to do is they're trying to make it user-friendly and very approachable, and they do it in a very visually appealing way, right? So these are different projects that are being worked on. And then there's coins, projects like Engine Coin. And some of you, a lot of you probably already know Engine Coins. Engine Coin is already an existing company today that is operating in the gaming and esports industry. And what they're trying to do is they got about 20 million visitors or users a month of their Engine product itself. And what they're trying to do is they created their own cryptocurrency called Engine Coin that is going to operate as a value transfer in their existing Engine product. So all of a sudden, you just have 20 million new users into cryptocurrency because one company has decided to open up its user base into the cryptosphere, right? So, there's a lot of cool stuff being worked on there. So now, why does blockchain matter? Some of this I've spoken around the security and the risks, but really ultimately, the disruptive potential comes in the fact that it's distributing trust. You are allowed any space that is doing a huge amount of work, and you have to trust that that particular domain is going to fulfill their responsibilities, is going to benefit greatly from blockchain. Just like, for example, the way Amazon right now is hosting all of its data servers in the cloud, in its AWS infrastructure, blockchain is starting to potentially try to disrupt that space with projects such as, SONM or SONM or Golem. And what they're trying to do is any kind of heavy graphic processing, image rendering, in terms of processing just massive amounts of data, high velocity trading, predictive modeling and big data analytics, machine learning algorithms. Those kinds of activities require a monstrous amount of computing power. And why blockchain matters in this space is it's very expensive to actually run that kind of infrastructure and run those products in Amazon or in Google servers. So what those projects Golem are trying to do is, why not just distribute it across the entire network of computers in the network, and each person who's contributing their power gets paid back in those tokens. So if I take my laptop and I say I want 20% of my laptop to be dedicated towards the Golem network, or towards processing, image rendering, or towards processing data analytics for another company from thousands of miles away. In return for that 20%, I want to get paid, $3 an hour, for example, right? So this is just a small example, but you think about the scalability and the potential of such an idea, right? So that's where that's really the benefit of blockchain. And everything that's being done, typically in public blockchains, is transparent. And I'll show you that. I'll show you that as part of the real life demo, where you can actually see and you can interact with the blockchain. You can see transactions. You can perform audits. It's truly beautiful. So now some of the negativity. I was thinking about in the past about the difference between an IPO and an ICO. So traditional firms, of course, raise funding and raise capital using an IPO model. And new blockchain companies are largely going to be, private sales / public sales through ICOs, and that's fine. Challenge now is that there's a bit of a retail mania, and because of that retail mania, it leads to mass hysteria, and that mass hysteria leads to folks who have access to cash and want to become overnight millionaires are jumping into this ICO bandwagon, and are just throwing money towards projects that really truly don't have fundamental value. Okay, they just have hype value, and that's where there's a risk with that model, because you have these hype-fueled blockchain projects that may or may not even evolve to actual products that users will use. But who benefits from that type of model if the product never materializes is the founders and the CEOs and the CFOs and CTOs of those blockchain projects, because now they have $20 million worth of funding, and they don't really truly have an incentive to go build that product other than their own professional obligation and their moral compass, and to keep them aligned and making sure that they're honest, noble people, right? And a lot of times that's not enough. So you're starting to hear of scams. You're starting to hear of exit scams, they call them, where, for example, somebody opening up a John coin, and some person named John wants to open up their own coin, and he goes and somehow convinces and influences groups of people to invest in his project, and then suddenly John disappears, right? John's to never be found again, and that's it. He runs away with the money. He uses different methods to be able to hide all of the funds that came in, and they're called like tumblers and obfuscators, and there's so many different ways to basically try to hide your tracks. But a lot of these folks are getting are rising and are getting caught, right? So there's some negativity with that. There's also some negativity and risks where when it comes to the security of keys. So for example, every single one of these cryptocurrencies that you're seeing, Bitcoin, NEM, Ethereum, Litecoin, most of them are using their own versions of a cryptocurrency wallet, and that wallet essentially is a set of numbers. And if it's a set of numbers, if you have access to those set of numbers, if you have access to the private version of those numbers, then you can access all the funds, right? And what ends up happening is, remember I was telling you around 80 to 85% of the applications you're seeing here are running on top of Ethereum. That means if an application that's running on top of Ethereum is immature and has security vulnerabilities that are being exploited by hackers and anybody with mischievous intent, then that application gets hacked. It doesn't mean that the integrity of the blockchain was impacted, but it definitely affects the environment, and it affects the perception and creates a negative sentiment of blockchain. So That's really why it matters. We talked a lot about this already. The one point I wanted to highlight is this, public, private, and hybrid blockchain. So basically, there are different versions of blockchains. Okay, that's the one thing I want to make it very, very clear. So there are public versions, which are really largely the ones that I was talking about today, which are Bitcoin is an example of a public blockchain, Ethereum, Litecoin, Lisk. Those are all different variants of a fundamental public blockchain structure, and I'll show you the different components of that. So public means, in this sense, it is open, transparent, and it is open source. So everyone can dig in and look at the code. Anyone can dig in and actually understand who are the enforcers, what is the network methodology that's being used, how are transactions being confirmed, how long has it been running for, right? So every transaction is a stamp in time, and it's completely immutable and it's immovable. So what that means is that if I send $1,000 to my colleague who's 5,000 miles away, and he receives that $1,000, that transaction will get a stamped date and time, and that transaction is irreversible, it is non-modifiable, and it is non-revocable. And at any point in time, 10, 15, 20 years from now, anybody can go back and look at the transaction ID, and they'll be able to see that I sent $1,000. And they'll see the wallet, they'll see the funds, they'll see everything is completely open, right? And of course, there's some level of anonymity and privacy there, but ultimately it is public and transparent. Some folks want private blockchain. So an example of a semi-private, semi-public is Ripple. So there's a lot of different variations where companies do not want to have open source public blockchains, which makes sense, and they want to have private versions of blockchains. And potentially when you see consortiums, so if you see a consortium of banks who are wanting to operate their own, their own remittance or back-end money transfer systems, they can create a private version of a blockchain that all members that are part of that consortium can participate and can use at nominal transaction fees, right? And that's what a lot of people are doing. That's what people are doing with the R3 initiative. I'm sure some of you have heard of that. So that's what a private blockchain is. And then of course there's the hybrid blockchain where you're seeing both ends, right? Then there's blockchain protocols, which are each of the blockchains use their own versions of protocols. That leads to something called consensus algorithms. I'm not going to bore you to death about what that is, but essentially consensus algorithm says anybody who's part of this blockchain will use these rules and these conditions, and everyone agrees to these rules with no gaming intent. So as long as there's no gaming malintent, and you follow the rules as established by the network, then you are fulfilling what your obligations are as somebody who's respecting the consensus algorithm. If you are a computer or a person who's a part of that network, you are either called a miner or a staker. And there's a subtle difference in terms of the ultimate impact of the network, but fundamentally there is a pretty big difference between what mining is versus staking. Mining is what Bitcoin requires to make sure that transactions are being processed and to make sure that that the network is safe. So that's what mining really is I was explaining a little bit before, is computers who are donating their time and donating their processing power, like their CPU or GPU, and then in exchange for that, they're getting a percentage of the pie, right? But it requires a huge amount of computational power, which leads to a bit of an environmental impact. Stakers, on the other hand, are donating their funds and locking in a percentage of their wealth and staking that wealth towards the security and safety of that network. So there's other platforms that are using staking. So now let's jump in and let me actually show you. I think I've covered a lot of the content here. So let me actually show you some real life stuff here. So let me flip over. I will show you. Let me show you actually one blockchain. So this is what you're seeing here is called Etherscan. So for example, Ethereum is one of the 1,800 cryptocurrencies. So actually, before I jump into this, let me show you. If you go into coinmarketcap.com, this shows you all of the different cryptocurrencies and most of the blockchain projects in this space today. And basically, if you look at and you can see there's just a huge amount, right? There's literally 1,800. And it continues to grow and grow and grow. CoinMarketCap really shows around like 99% of them. But you can see Ethereum, in terms of its market capitalization, it's ranked as number 2, right? And it's got the most users. It's got almost 800,000 transactions a day that are being processed on the Ethereum network, versus around 250 to 300,000 on the Bitcoin network, okay? But these are all the different projects. So you have Litecoin, EOS, Bitcoin Cash. These are all the different variants of a cryptocurrency. So now if I want to be able to go into Ethereum and I wanted to be able to look at transactions, I would need to use an Explorer, right? And an example of an Explorer, and this is a perfect example of the technology, is if I wanted to be able to see any transaction, any point in time, I would have to go into etherscan.com, which is, again, a blockchain explorer for the Ethereum network. And this allows me to say, I want to see if this one example as an example, right? So this is a transaction hash, so equivalent to a transaction ID, like you would see through a PayPal process. You see the from address. So this address here that ends in C53 sent around 2.99 ethers, so $1,300 equivalent in terms of ethers, to this address. And if I wanted to dig deeper and I wanted to say, who is this person? Of course, you're not going to be able to identify the person, but I'm looking at their wallet now. And I know that around 22 hours ago, they received the 3 ethers. And then 46 minutes ago, they sent those 3 ethers to a different address. Okay. If I want to look at the recipient, so the person who's receiving those funds, you can see that this is probably most likely an exchange, but it's hard to say. But you can see that they're receiving, it seems like they're receiving 2.97, 3.17, 2.84, and it seems fairly often. Okay, so if you want to ever dig deeper, it allows you to dig deeper, and you can understand that it looks like they have some IX ledger. So this is just an example. This is a wallet. So these are different wallets, and then you can start seeing all the different wallet components, right? So without jumping into too much detail here, Etherscan, again, is a blockchain explorer. I'm just walking you through one example of a transaction that's completely transparent, and you can see that it's a transfer of funds from this address to this address. It was timestamped 45 minutes ago. Now, the beauty of this is that I can see everything, right? So I can see if, for example, if the transfer didn't go through and it wasn't confirmed by the network, I could see that. But I could see that this transaction was clean. It had 174 confirmations, which means that, Ethereum as a platform, it processes transactions around every like 15 seconds or so. That's typically the processing time for an Ethereum transaction. So during that time, it's 174 confirmations that happened. Okay, so that's pretty significant. So that's just one example. Now let me jump back in and go back here. So that's really the just one example of an application. I'll show you afterwards. It's a decentralized or centralized exchange. And now let's just take 1 minute for another poll, and we will pop that up right now for you. So this one's awesome. How much Bitcoin was used to buy 2 pizzas in 2010? So I should probably hide the results, otherwise everyone's going to converge to the mean and probably just select the most commonly responded answer. It's just incredible if you think about how little everything was worth years ago. Okay, so let's open that up again. All right, let's end it and let's share the results. So interesting. So a lot of people selected 100 Bitcoin. So the answer is actually 10,000 Bitcoin. It's just like it's unbelievable. That's why I wasn't exaggerating when I said that. 10,000 Bitcoin at its highest. So in December 2017, before the derivatives market and the futures market opened for Bitcoin, 10,000 Bitcoin would have been worth $200 million. Okay, now 10,000 Bitcoin is it's around like 6150, you know, a Bitcoin. So it's 61 million. It's still a substantial amount, but it's not 200 million. Back in 2010, this is you know, widely known as the first real public transaction that happened on the Bitcoin network. A year after it was released to the public, where one person was just begging people, "I will pay in Bitcoin if you can just please order me pizza." And it was just a guy, just a, you know, it's a bit of a joke, but really he paid 10,000 Bitcoin to some individual who now is, you know, is doing extremely well. So those are that's the poll. So how does Bitcoin work? You know, I think I covered a lot of this, to be honest with you, but one thing I do want to highlight here is something called public key cryptography. And this is already jumping into a little bit too much technical speak for, I think, for the wider audience, but I will just give like a few sentences on it because of its importance here and the implications of it. But really, there is, in information security, there is different forms of cryptography that are being used, which are different methods for securing data. Okay, and that's what cryptographical science and research really pursues is the safety and security of data and in blockchain space. That type of cryptography that's being used in some cases, it's called public key cryptography, and the importance of this is in terms of managing the cryptocurrencies. So the way that wallets work is today your physical wallet, you have you know, US or Canadian or you know, a French euros, for example, in it, and it comes in paper and coin form, but someone can just steal that wallet, right? It's irreplaceable. You can't clone it. You can't just, you know, duplicate it and transfer it across the world, right? So it's a physical wallet, or even you know, some Bank of America account. You have your funds, and you know, you're just hidden by just a standard password. Somebody can pursue and through a phishing attempt can steal everything, right? So public key cryptography, what it helps you to do is it allows for cryptocurrencies to have to give the ability for users to keep their funds safe, and it uses public keys and private keys. So for example, when I was showing you this, when I was showing you these, so the from address that was sending the 3 ethers, this is a public key. Okay, so this DC53, the address that's ending with DC53 is a public key. It's associated to someone in the world. It could be John Smith, you know, in Australia. He could be the owner of DC53, or it could be you know, a Jessica Smith that is living in France, for example, right? So we don't know who the true owners are of these public keys, but each of those individuals has something else called a private key, and only using the private key can they then access the funds. So this public key cryptography is key and central to a lot of the cryptocurrencies. There's also something called, you know, hash cache functions around trying to make processing of transactions safe and secure. I'm sure you've heard of proof of work and proof of stake. So those are different consensus algorithms that are being used by different cryptocurrencies. Okay, so I quickly mentioned consensus algorithms. I didn't give you examples of them, but really examples are proof of work, proof of stake, you know, proof of bandwidth, proof of space. There's dozens of variants which are essentially trying to make sure that in a verifiable way that transactions are secure and that they're efficiently being processed. And all of that is being on the blockchain like we talked about, right? So let me just give you a very simple framework here. So the way that a distributed ledger or a blockchain works is that you have transactions, right? Like we talked about, I was showing you an example of a transaction. Each of those transactions fit into blocks, and then those blocks are placed in successive order, right? So block 1 is followed by block 2, which is followed by block 3, and it continues to build. And it continues to build and build and build. And as the network grows, you have tens of thousands and hundreds of thousands of blocks that are being processed that then contain transactions. The easiest way for me to show you how that actually works is if I just show you an example of a transaction. The one I just showed you is, transaction 399, account A is sending 100 tokens of assets to account B. Now this asset can take in any form. An asset can be defined as money. It can be medical licenses. It could be Bitcoin. It could be token registration rates. It could be, event tickets for a different concert. It could be, a credit on the Amazon server. It could be credits on that are being used for an arcade. So think of the potential here around the transferability of assets and how you can have an asset that never expires. So imagine the potential around trying to pursue membership rewards. And if I was able to transfer my membership miles from my American Airlines to my membership miles that are in Delta, or if I wanted to be able to transfer my membership miles with American Airlines without invoking a pretty significant transfer processing fee to somebody else who has an American Airlines membership rewards program, right? So you take the vendor or the intermediary out of the exchange and just transfer the asset directly to the recipient, right? So this is the sender and it's the recipient. So that gives you a glimpse into it. Back at a really high level, transactions fit into blocks, they fit into a ledger, and then you distribute all of those transactions across. And this is what a blockchain is. I'm sure a lot of you have seen this before. You've seen this, this circular image here. All of these are they're computers, or you call them nodes, and these computers are all keeping the network safe. Okay. So what are some key features before we jump in? And I want to show you a few more applications here. The most important feature of the currency today is that it's accepted, that it's durable, that it's divisible, fungible, scarce, transportable, recognizable, non-counterfeitable, right? So these are really the nine features of a currency, and they also actually form the canonical definition of a cryptocurrency, right? And I mean the canonical definition of a cryptocurrency in a lot of different ways. It's not just these core 9. It includes hundreds and hundreds of innovations on top of just traditional U.S. or Canadian dollars, for example. If I receive $10 today in U.S. currency, can I somehow prove that it's not counterfeited or it hasn't been laundered? Can I somehow prove that can I send that money across the world at a fraction of a cent and it'll get sent there in 10 seconds or less? No, right? But using cryptocurrency, I can do that. I can literally send $100 million today from Phoenix, Arizona, which is where I'm based, to someone out in East China, okay? And I could send that, and for a fraction of a cent, and the network's going to process that transaction. The recipient receives the 100 million, and they only get processed a very, very small, negligible fee, right? Just a cent or two. Compared to if you're using the traditional banking route, that would cost, it would cost hundreds and hundreds of thousands, potentially millions in processing fees. The latency of that transaction is very high. You might have to wait up to 4 weeks for that transaction to clear and to go through the proper channel. Okay, so regulatory complications and compliance issues aside, because that's a separate discussion, the true brilliance and the implications of this technology is just astounding. So think about just that one transaction. Think about the ability to now all of a sudden crowdsource the purchase of an apartment building. So if you have an apartment building that has 10 units that you're renting out to students close to a university, you, instead of going through one central real estate developer, you can have thousands and thousands of fractional investors that are spread across the world each have an own stake of ownership into the revenue that's being made through that apartment complex. Okay, so I'm just giving you a glimpse into different examples of that are being used today. Okay, now I talked about Ethereum. I wanted to show you one thing about Ethereum. I talked to you about smart contracts around, ASIC programmability, auto-enforceable logic. I want to show you an actual smart contract so you can see them. I want to show you an actual decentralized exchange. So before I do that, I do want to clarify one thing and make sure I'm crystal clear on this. So today, when you want to buy a stock of Microsoft or a stock of Nintendo, you have to go to a traditional online broker that is very centralized in nature, such as Charles Schwab, E-Trade, any of the major ones, right? So any of the traditional standard brokers that are out there. So Charles Schwab, TD Ameritrade, like E-Trade, there's dozens. And if you want to do that, it's only available from 9 or 9:30 till 4 every day, Monday through Friday. It's always closed after those times. It's closed Saturdays and Sundays, and it's always got to be within those locked business hours. And every standard traditional exchange uses its own hours by that country, right? So China and Hong Kong and London and so forth use their own regional timing. Right, so typically you can't exchange at any one point in time. You have to fit within the confines of their schedule. Okay, now those are all centralized exchange. Now imagine the ability to pursue a decentralized exchange. Okay, so I'm giving you an example today of a decentralized exchange, and I'm seeing some questions around what's the difference. The key difference is here. This decentralized exchange that I'm showing you, it's just one example. It's called Fork Delta. Okay. There are dozens and dozens of these decentralized exchanges that are popping up and that are solving a real problem. And the real problem that they're solving is, rather than me using a centralized exchange to transfer and to convert some of the cryptocurrencies that I have, like the Bitcoin, Litecoin, Ethereum, rather than me transferring my cryptocurrency into that centralized exchange and then trusting that exchange to not get hacked or to not shut down or to have their website just crash, in the middle of a transaction. So my risk exposure is very high in those situations where I'm using centralized exchanges. In a decentralized exchange, what I can do is I can plug in my wallet directly on top of the decentralized exchange. Okay, so let me give you an example. So there are wallet apps like MetaMask that allow me to say, I want this wallet. Only I have the keys to this particular wallet. Right? I can have a private key and then there's a public key. Only I have this information. Okay. Once I have this, and this is just a standard Chrome extension where it's called MetaMask. There's my Ether wallet. There's so many other extensions where you can just add in these wallets, right? But it's stored locally. It's not stored anywhere else. Now that I've enabled the wallet, it's been configured. I can go into Fork Delta, and this is the wallet. This is my wallet here with the funds, and I can go and buy and sell. I can buy and sell cryptocurrencies with others. Okay, this has millions of users across decentralized exchanges today that are growing. Now, if you wonder, okay, well, what's the advantage of that? Well, the advantage of that is that I'm not transferring the cryptocurrency into Fork Delta. I'm actually just transferring the cryptocurrency from my wallet to the recipient's wallet. More importantly, the smart contract. So the smart contract that's running this entire platform, I can actually dig into it. I can look into the code. And I can use the same website that I was showing you before, which is Etherscan. And I can go into, if I just click read contract, I can go into the code. I can see every single line of code. It's completely transparent. It's auditable. It allows me to dig deeper and look at the integrity of the code to perform a formal security audit, right? And this is cool because some of what we do at Blockgram when we're trying to screen and review candidates' proficiencies and their relevancy for specific roles they're applying to. Some claim that they've written these smart contracts from scratch, and they claim that they haven't plagiarized or they haven't fraudulently copied, other smart contract code or blockchain development experience they have. But to us, it's very straightforward to cross-reference what they've claimed is theirs versus what is actually publicly available. So some of you are familiar with the whole turnitin.com platform where you can submit assignments at different institutions where it'll ensure that your assignment is not fraudulently copied or doesn't have a high plagiarism rate, right? Based on some kind of reference index of like a massive amount of data and submissions from different years. It's the same concept here. It's basically using like a Lendit, a Turnitin.com version that we use purely for recruiting, and it's a platform that we have access to, right? So there's no lying here. It just goes back to the ethos of the network. There is nowhere to hide when it comes to blockchain. We know everything. All the code is here. It's all completely auditable. I know exactly what's happening. I know that the amounts filled are enacting these particular functions. I know the variable names. Right? It's all for everyone to see, right? And that's just the beauty of it, right? So if I want to read it, I can read it here. If I want to go into the actual code that's written in a language called Solidity, so Solidity is a JavaScript programming language that is being used today by Ethereum to write smart contracts, okay? And all the code is here. So I see the contract tokens, I can see the total supply, I can see the event transfers, the event approvals, all of that is here. You just think about that. So it's just awesome. I mean, it's just that's the way everything is right now on blockchain. Is that you just projects that are completely open and are growing are the ones that are getting the most amount of support. So this is Ethereum. This is Fork Delta running on top of Ethereum. Now there's literally so many more. So there's this is a website called DApp Radar, and this is where you can get decentralized applications, and you can see all of them. You can see Fork Delta here. Right now it has 1,600 users. There's about 1 million ethers that are being transferred. There's CryptoKitties, which allows you to be able to own your own version of a digital cat, and it's actually pretty cool. It's very creative. And same thing with Panda Earth, Crypto Striker. So these are all collectible and game-based applications that are running on top of Ethereum. So this is just DApp Radar. There's a lot of really cool other ones, like there's State of the DApps, which is where you can actually go see real-life applications of cryptocurrency and blockchain technology. Okay, so there's an Ether World Cup. Like, look at this: earn ETH by training superstars. So if I wanted to click that, I can dig in and I can see the number of active users, number of transactions, the values per Ether. And this was just released just a few days ago. And it's just a whole bunch of, it's amazing. Like, this whole space is just exploding right now because people are finally realizing, this is a pretty incredible space. So if anybody ever asks you, is blockchain technology booming? Is it just a fad? No, there's almost 300,000 developers and software engineers and computer scientists that are dedicating their blood, sweat, and tears towards growing and expanding this domain. Okay, so that kind of co-location or movement of just human capital and brain power from traditional financial and traditional technology platforms into blockchain technology is a massive shift, right? And that shift is preceding an even bigger established shift that's going to happen when traditional companies are finally going to jump in, and which they finally are now. So that's really what I wanted to show you. So let me see if I can see if there's the questions here that I can try to answer. So one question we got is, what is the difference between just a traditional peer-to-peer network and a blockchain, right? So it's a very good question. It's the same question as, what's the difference between BitTorrent technology and a distributed computing, blockchain infrastructure, right? So, and why did Tron, for example, Tron is one of the major cryptocurrency projects. Like it or not, it is definitely well known. They just bought, the BitTorrent foundation, essentially, the BitTorrent platform. So peer-to-peer, it allows you to transfer value from one party to the next. But when you're talking about completely decentralized distributed computing, you're talking about all the nodes operating under one consensus and one rule, and everyone has to abide and conform by those rules. So I actually have a slide here that I wanted to show you that has that here a little bit. It's a little bit here, but you can see a blockchain design where each person who's donating their computer, contributing towards the safety of the network, has a version of the blockchain. Okay, and each person who's contributing to that has a version of the blockchain that is correct. If one person in that network tries to modify the contents of that blockchain or tries to modify the contents of that ledger, then they will be punished and potentially removed from the network, just by using the logic and the rules of the consensus, right? So that's really the key difference. What are examples of blockchain being used other than transfer of value, like cryptocurrencies? I've covered some of these, you know, there's literally thousands and thousands of applications. There's, of course, trading, investing, hedging against the traditional market. Right there's some fundamental value in terms of potentially a long-term of wealth. There's called Digix Gold, which is a digitized version or a digitized / cryptocurrency version of gold that is being used, that is actually physically backed by real gold that are held in safes, but it allows you to transfer it without actually using, you know, futures or ETFs or any kind of derivative variant that runs on top of the actual physical asset. So those are two applications. There's applications around collectibles, around crowdsourcing. So it's the ICO is really the biggest, another awesome application here, where it's an application of how to raise capital for thousands and thousands of participants that are scattered across the world in an unobtrusive or in an easy way, right? That's the beauty of an ICO or an ITO. You can do it very quickly and you can ramp up and get the funding. This is the first time in history that we can finally fund open source projects, right? So if you talk about, you know, Apache or some of the Linux and some of the massively famous open source projects, you know, I think personally, they would have rose to prominence and popularity faster if they had access to funding like the way that some of these blockchain projects do. So this is the first time that you can actually back some of the projects that you enjoy and respect. Other applications is auto-enforceable logic. If I wanted to be able to, if you want to disrupt the entire supply chain and logistics space, that space is exploding right now, because there's those companies are all jumping in because they're realizing that there's a massive amount of friction and logistical nightmares and mundane tasks that are taking place between, you know, transferring a huge crate of goods from Houston, for example, all the way to Bahrain in the Middle East, right? There's a massive amount of transcription and text and invoices and re-invoices, and there's a massive amount of pressure and logistical errors and erroneous errors that are taking place from the first transaction all the way to the end. So what if there was a way to be able to see the entire life cycle of that transaction on the blockchain? And if you can see if somebody tried to modify the content of the box based upon the weight, or if somebody tried to modify the content of the invoice, you can see all of that on the blockchain, right? So I can go on and on about different blockchains. So there's an example, how to make available, how can you make your existing CPU and GPU resources available for mining and collecting payments for it? To be honest with you, the easiest way is to just jump in, like just experiment with it. So you can literally go in, and we actually have a course. So we developed a course called Foundations of Blockchain here that I'm showing you. It's on Springboard, and Springboard, as I'm sure a lot of you know already by now, is the leading, you know, future-proof, ready educational institution that allows you to take courses such as these free learning paths, but they also, of course, have paid for much more advanced courses, which are focusing on the computer science, software engineering, data science, digital marketing spaces. And an example of one course is the Foundations of Blockchain here, right? So this is just a course that I developed that walks you through around, you know, why learn blockchain? What will I learn? It's quite extensive. I mean, this is a course that it's going to take you, you know, 21 hours of just core uninterrupted focus, right? That there's about 60 resources. There's just a huge amount of content there that has been prepared and curated for your benefit. So back to your question around existing CPU, GPU resources, there's a whole section here in the actual course around mining. Okay, so that's what I wanted to, you know, you can take a look at that, and it's right here. basically section 3, how does blockchain work? And then I go into extensive detail around how Bitcoin mining works, cryptocurrency mining options, cryptocurrency hash functions, proof of works. So basically, depending on your CPU and GPU, that will dictate your ability to mine or stake effectively and profitably, right? Because the amount of money that you would make off of mining or staking is dependent on the number of participants, on the level of competition, and on the market, how saturated the market is at that particular time, right? So I spend a huge amount of time mining and staking, and it's just, it's a pastime for me in terms of setting up a rig, and it's just awesome. And the mining that I do is I love setting up a mining rig that essentially mines multiple cryptocurrencies based upon which ones are the most profitable at that particular point in time. So, like Litecoin uses a standard consensus algorithm that is shared by many, many, many others, right? So the one that Bitcoin uses is something called like SHA-256. Some of you have heard of like SHA-512 and all of that. Those are all different cryptographic hashing algorithms that allow you to mine. Now, other questions, is there any suggested wallets to use? Are there better ways of coins other than exchanges? Absolutely. I mean, so MetaMask is one. My Ether wallet is another big one. Ledger Nano S, that's the one that a lot of people use in terms of offline cold storage. There's also Trezor, of course, one of the first ones that finally now has Ethereum-based crypto holding. And so that's that question. And then another question is around, in your opinion, is the best way to stay involved in crypto other than trying to make, of course. So my opinion is always, focus on the technology and on the disruptive potential of how amazing this space is, and just imagine the direction it's going. Now that everyone is jumping in and it has a huge amount of attention and concentration of talent, right? So wherever you have high concentration of talent, you have high potential of disruption and potential exponential growth in terms of funding, potential, and et cetera, et cetera. So that's that. And then how to make available. So we did that already. So I think we're at the top of the hour now at this point, but we do appreciate your time. Thank you very much. And I really enjoyed the opportunity of speaking with everyone today. So thank you for everything. If you have any questions, you guys can contact me directly, or if you're looking for any resources that are in the blockchain space, such as blockchain developers, blockchain architects, smart contract engineers, or any data scientists, data architects, data modelers, product engineers, product developers. That's my bread and butter, and I love what I do. So check us out at blockgram.com, BLOCKGRAM.com, and or just email me at Basel@blockgram. So BASEL@blockgram.com, and would love to hear from you. I'd love to hear your feedback as well. Thank you so much, and you guys have everyone have a wonderful day. Take care.